In the previous video, we have dealt with one-dimension objects, vectors. Now we're going to move on to 2 dimensions or more, getting closer to the way we are used to seeing data. Back to our studio, before I actually introduce you to Matrix, just wanted to point out that when you are in the editor, any line you start with a pound sign is considered to be a comment. Doesn't matter how many you use, and you can use space after them or not. Those you can execute and nothing happens. No command was executed, no output was generated here, no object was created here. They are just comments that you can use to keep your scripts really organized. And you can also put comments in the middle of a line. So for instance, if I run this line here, the object A was created, but the object B wasn't, because whatever comes after the pound sign is ignored. So here's the function matrix, and for you to understand what this function expects, I have here the help for matrix, and I've pasted here to guide us the order of arguments that the function is expecting. It's expecting you to provide the data. Here I'm going to provide this sequence of 6 numbers as the data, the number of rows, the number of columns. If you want to fill data in by row, we're going to understand in a second, and if you want the dimension names, which the default is null, so you don't need to provide one. In R, if you break a line in an obviously unfinished line, and you try to run that line, R understands this line is not finished because you started a parenthesis and you didn't close it. So it will keep waiting for the continuation. So you can run all those lines and it's not going to close until it finds a matching parenthesis for that start parenthesis. This should be used to keep your scripts really neat and easy to understand. So here I've started a function and I've put 1 argument per row to make it really easy to understand. Let's see what the result was. So I created an object with 2 dimensions, 2 rows and 3 columns. The data was filled in by row. So first it filled in the first row and then the next one. If I run the same command but by row equal to false, and now I compare the results, you can see here 2, 4, and 3, and here it was filled by column 2, 4, and then 3. If here I've named the arguments, if you give the arguments to a function in the order they are being expected, you don't need to name them. So you see from the help that it expects data, number of rows, number of columns. So these will generate a matrix with 12 numbers, 3 rows, and 4 columns. But if I do choose to name the arguments, then I can put them in any order I want. I can even call any call first, but the result will be the same. The equal sign you use within functions is another reason why you should do assignment like this instead of like this, just to differentiate from when you're giving values to arguments within functions. So here I'm not creating an object called nCall. I'm calling a function and saying as an argument nCall, please use the value 4. So we're going to try to stick to using equal inside functions and the assign operator when we're trying to create objects. To try to simulate some more meaningful 2-dimension data, let's go back and look at vectors again. I generated those 3 vectors. ID is just a sequence from 1 to 15. Weight is a sequence of 15 random numbers taken from a normal distribution with mean 75 and standard deviation 4. Remember, if you want to understand what I'm doing with one of those functions, just put question mark, the name of the function, to get the help and understand what each of those arguments mean. And height is, again, I called a function that generates 15 random numbers from a normal distribution with mean 165 and standard deviation 0.2. So I have 3 vectors, and you could see those three vectors exactly as the columns of a data set. So I have a data set where I have the ID of 15 study individuals, the weight of those 15 individuals, and the height of those 15 individuals. If I want to put this together in a matrix, I could do using the matrix function that I've used before, and then as data, I'm going to provide all those three together. So I concatenate all those three. For the number of columns, I want 3, because I want each vector to become a column. And I shouldn't fill by row, I should fill column by column, because that's how my data originally was. If I do this, I get this matrix of 15 rows and 3 columns. Column 1 was the ID, column 2 was the weight, and column 3 was the height. But I lost the names. If I use cbind, it's much easier. Cbind means bind by column, so it means I'm going to provide 3 vectors, each of them is going to become a column. And then I create a matrix that looks the same, but I have the names on top here. We're going to see how those names become useful later. As we've said before, matrices have 2 dimensions, so if I call what are the dimensions of this object study group, it has 2 dimensions, 15 rows and 3 columns. You have to remember this. The dimensions are always giving first rows, then columns. So dimensions create a vector of 2 elements where the first is the number of rows of the object and the second is the number of columns. I showed you cbind. Let's say that now I get one more study object and I want to add a row to this matrix. Then I use rbind. What am I going to bind? I'm going to bind the initial matrix, and at the end I'm going to add one more row, which is a row created by concatenating the next ID, 16, the weight of the next subject, and the height of the next subject. If I run this command, my study group matrix now has grown by 1 row. And if I check again the dimension, now it has increased 1 row. When we're dealing with vectors, we use the square brackets to call specific elements in a vector. Now we're dealing with an element that has 2 dimensions, so we have to provide an index for the row and an index for the column. So if I run this command, I'm asking R to see from the matrix study group the 3rd row and the 2nd column, always separated by comma. So before the comma you give the rows, after the columns, and just as we saw before, you can give as many columns or as many rows as you want. So I could ask row 3, columns 2 and 3. I could use C to ask a non-sequential number of columns, so the 1st and the 3rd. If I leave one of those indexes empty, it means give me every row for the 2nd column. It provides it as a vector because it only has 1 dimension. It looks like rows, but you know it was a column. It doesn't matter. As long as it's 1 dimension, it's 1 vector. It doesn't matter if it was a row or a column. Here I am asking the 3rd row every column. And just as we saw with vectors, you can use the index to assign a new value to a position specific. I won't say much about matrix math because we rarely will do any operation with our whole data set at once. Usually we'll either choose a row, for instance in the example above, all the information for one individual, or work with columns, the height for all individuals, for instance. But you should know that you can multiply a matrix by one number, a scalar, and in that case all elements get multiplied to that number. You can sum matrices with the same number of rows and columns, and you can multiply also element by element, which is not the same as the matrix multiplication that you may be used to in algebra. Here you're just multiplying member by member. So when we created study group, either by using the function matrix or by using column bind, it created a matrix. So we saw that vectors could be character, they could be logic, they could be integers or numerical. Here we're just saying it's a matrix because it has 2 dimensions. If you want to know whether some columns are characters or numerical, you would have to ask that column by column. A matrix only accepts elements all of the same type, so either all numerical or all character. When you're dealing with data, that's rarely the case. So here I have one column that would be character, one column that would be numerical, and one column of yes or no, which you could see of as logical, true or false. To be able to put all those vectors together in a 2-dimension object, I cannot use a matrix because the matrix would convert everything to character because of this column. I have to use data frames. So that's the next thing we're going to see. So I've simulated here what something like this data would be like with one more column. So I have 4 vectors of information. I have the name of the cows, I have their lactation, I have information about whether they're vaccinated or not, and I've tested them for disease X and I have the results of their ELISAs. So I created 4 vectors. Let's see what type of vectors those are. Cow name is character, it's all text. Lactation is numeric, I only gave it numbers. We've been talking about classes since the last video. What you should know is that for every class that exists, you can test whether a vector belongs to that class or not. So is lactation an integer? So it's a function, and the result is always true or false. So in this case, lactation is not an integer, it's numeric. I wanted it to be an integer. I wanted R to know lactation cannot take the value 1.5. It can only take the value 1 or 2 or any other integer. So I can now use the function sinteger to force it to become integers only. So I used sinteger to test and I use sinteger to force it to become. So I want lactation to be what lactation used to be, but now force to be an integer. If I ask again, is lactation an integer? It says yes, it is. What's the class of lactation? It is an integer, just as I wanted. Vaccinated is logical. ELISA is numeric, as I want. It can take decimal values. If I were to force ELISA to be an integer, it would round them up. But I didn't assign that to ELISA because I don't want that to happen. And just while we are on the subject of those functions that test if a value belongs to a specific class, I'm going to create a vector of 5 elements, and then I'm going to add a 10th element. As we've seen the first video, R is going to fill in the missing positions with missing values. If I ask is NA to this vector, R is going to return another vector also with 10 elements, saying this is not NA, which means it's not a missing value, and true only for the missed values. I can use this to drop or replace missing values by using the function we saw in the previous video, which is going to find what are the indexes of the missing values in that vector. It's also important to know that R sums logical values as false meaning a 0 and true meaning a 1. So if I sum the result of a logical test. The result is how many times there was a true. So I can use sum is NA to find out how many missing values there exist. And if I want to replace those values, I can find them by calling the object, indexing, and the elements I want to call are all those elements which are NA. So it's going to return from any vector the missing values, which in this case would be those sitting on position 6, 7, 8, and 9. So enough with the classes and the missing values. Let's finally get to handling some data. Remember, I had 3 vectors of information. Before, I had used cbind to put them together into a matrix. If I use cbind here, it will do the same. It will create a matrix. The problem with that is because those vectors had different classes, it's going to convert everything to character. That's not what I want. What I want is an object that has 2 dimensions, rows and columns, so it will take several columns, but can handle different classes. That's a data frame in R. So to create a data frame, I have to use the function data frame, and then I can provide all the vectors separated by commas. So if I run this, I get now a data frame, not a matrix. You don't see the quotes in any of those values. If you ask for the class, it's a data frame. And now this is the type of data handling you would do. On the data frame, because it has 2 dimensions, all the indexing will work the same way as matrices. You call the indexing and you first supply a row and then you supply a column. You can supply a column based on its position, first column, second, third, or you can use the name of that column as long as you remember to put in the quotes. So if I run this here, it's going to give me only that column. If I ask for the class, it's not a character, it's a factor. That's a class we haven't seen before. Factor is how R calls the categorical values. By default, every time you add a character vector to a data frame, R tries to coerce it, which means change it to a factor. This is actually helpful because usually when we're working with data, the only reason to have some characters there would be to assign groups. For instance, test group, control group, feed group 1, feed group 2, males, females, and so on. Even though this default behavior is usually very useful, in this case, I didn't need it because I don't want cow names to be factors. Those are not groups, those are really just character, just text, just the names of the cows. So I'm going to force it to be a character by explicitly saying, go to this data frame, every row gets this column, force it to be a character, and then put it back on that column in the data frame. And now if I ask for the class of that column, it's a character, it's not a factor. It's different, for instance, of having a feed group, and here I'm just going to create this vector that repeats A 5 times and B 5 times, so that I assign the 5 first cows to be feed group A and the next cows to be feed group B. A vector standing alone like this has the class character. If I bind it to the data frame I had, so I'm going to bind the data frame and add one more column, the class of that column is now a factor. It coerced my character vector to a factor as soon as it was in the data frame, which will be helpful later so that I can extract summaries, for instance, by feed group. Interesting enough, if you already have a data frame, then you can use cbind, and it's not going to coerce things to be a matrix. It's going to continue thinking this is a data frame. So use data frame when you first want to create a data frame. After that, you can add columns using cbind. It's safe to do that. And I used a bit of indexing up there, but just to reinforce, it's the same as matrix. You can call a row and a column, and you can call columns by their names, or you can call columns by their positions. You can leave row empty to get every row. Same thing here. The interesting thing with data frames, and we're much more often going to use it, is that you can call the vectors by using the $sign after the data frame name. So when we want to index an entire column, we can do this, but more often we're going to do this. Because then it's like seeing lactation as just an object, but it's not an object that is floating on the environment. It's attached to this data frame cow study. In some art tutorials, you see ways to deattach and create one vector for each column of a data frame. I don't recommend that. I think the data frame should be kept together so that you don't mess up by, for instance, sorting or doing something that changes the dimension of one vector but not the others. We usually work with named columns, but very rarely named rows. But there is usually within your dataset some sort of identification for the individuals or for the rows, and you can use that to call in the information for specific individuals. So while you can call a column simply by doing this, to call a row, you can use a condition attached to what is the ID vector, in this case, cow name. So for instance, I want to extract from this data frame, and then I index it, every column for the specific row of cow mimosa. So the cow name must be equal. I'm using double equal because I'm testing if the cow name is equal to mimosa. But remember, even though I'm calling within the index of this data frame, R doesn't know what cow name is. It only knows what is the cow name attached to the data frame cow study. So even from within the index of cow study, I have to say cow study $sign cow name. And then it's going to give me the single row of the cow mimosa, but every column. So we have seen dimensions for matrix, and it's the same for data frame, the number of rows and then the name of columns. You could ask specific n row, which is the number of rows, and call, or remember, just pay attention when you ask for dimension that it gave you a vector with 2 elements. So you could just say from dimension, get the first element. You can index the result of this function, and it's 10, or the columns, which are the second part of the dimension. You can use those functions I just showed to reassign. So you could call names to find out what are the column names, or you could use the same function to assign new column names. So this function just calls what are the current call names. But you could say, okay, take the current one and assign new ones. I'm going to store the old names in a variable first because I don't actually want to change them. I'm just going to show you the data frame currently looks like this. Now I'm going to say, okay, take the column names of the cow study and assign it these new names. If I call the data frame now, it has new names. There are two reasons why we should get used to working with column names and not column numbers. The first is it's not good to call things by the column position because those could change as we manipulate our data. The other reason is that we'll usually be working with really large data. R is not meant for you to see the data. If you try to call in a really large data frame in R, it won't even show you all of it. It will only show up to a certain number of rows. The goal of R is to get your data in and do analysis on it. All you need to see about your data is understand the structure. So when you bring data in, you're not going to try to see it. You just want to understand what columns does it have with information. and what type those columns are. So there's a few functions that are very useful to know. One is structure. So when you have a data set in and you call structure, it tells you what are the variables it has associated with it, so the columns. As I said, you will call each column by saying cow study, $ cow name, and it says this is a character, and it gives you a sample. Lactation is integer, vaccinated is logical, and feed group is factor with 2 levels, A and B. It's a very nice way to show the structure of a data set. Summary will give you a summary by column. And I said in the previous video that it's nice to know the classes because R behaves differently for every class. And here you can see when it's a character, the summary just tells you, well, this is a character. But if it's numerical, it gives you summary statistics right away. For logical, it will give you a summary of how many falses and true, the same way as factors, how many observations there are in each group. And here it also told us whether there are any missing values. There aren't. It's a very nice way to get a quick summary of your data. If that's not good enough for you, you want to see how the data look like. You can use head. By default, it shows the first 6 rows. You could say head 5 and it shows the first 5 rows of data set, and tail shows the last 5. But it's nice because you have the column names. Table is a nice way to get summaries specifically. It's if you use only one column, it's similar to what you get on the summary, the number of observations in the data set that are false or true, because this is a logical. You can actually combine and say, okay, table on the rows whether a cow is vaccinated, and on the columns what's their lactation. And then it just tells you how many cows are not vaccinated and are on the second lactation, for instance. That's the overview I wanted to give you of data frames. It won't get more fun than this until we bring in some real data soon. I just wanted to emphasize that R doesn't have to work with only 2 dimensions of data. It can have more dimensions. So arrays are like matrices, but you add yet another dimension. You could add 3, 4, as many dimensions as you want. So then you have row, column, and a 3rd dimension, and you could have a 4th dimension. You can also create it with array the same way as matrix, just by giving the data you want to put in and the dimensions. So it would look like this. So this dimension 3 just means I would have then 3 matrices of 2 rows and 3 columns. So 2 rows, 3 columns, 3rd dimension, first of 3rd dimension, 2nd and 3rd. Can be really cumbersome to operate like this, but you can give it dimension names. So I would work with arrays, for instance, if I'm conducting an experiment where I test cows every day with multiple tests. So maybe I want to, because I have already a result for each cow and each day that already kind of fills 2 dimensions, I could choose to put the test type on the 3rd dimension. So when I look at my result now, it's a bit more explicit that the rows are the days, the columns are the cows, and the results of each individual test were put in a different dimension. And also I know that I can always call a specific cow on a specific day, a specific test, by calling back that array with the dimensions of the day, cow, and test I want. So it's just another way to keep organized. You could always just flatten it to 2D by creating a column that says the test, but then you'd kind of repeat each cow and each day 3 times for each of the tests. So it's your choice whether you want to work on this format or just a really long table, sometimes for calculations that you just want to do in all dimensions or for all tests at the same time. Working with arrays is easier. It's not that common that we use arrays, but it may be a bit more common that we use lists. So lists are just a way to group together in R anything at all that we want. So here, remember, we have this data frame. Sorry, it's a matrix called study group because it only has numbers. Then we had the data frame called study, and I'm going to create a vector from 3 to 8. I'm going to create a character vector, and then I'm going to create a vector of one element, so basically a scalar, the number 5. Those are all different classes and different types of objects. I can list them all together by just saying list and then putting all those elements separated by commas. I will assign them to list. And again, I can break this command in 2 lines because I finish with a comma without closing my parentheses. R knows, just going to wait for the second line there. If I ask for the dimension of the list, it says null. Lists only have 1 dimension, so you can't call the dimensions, you have to call the length. The length is 5, which means I have 5 different objects on this list. One object is a matrix. The second object is a data frame. So the list just kind of groups it all together, and then you have to index lists with 2 square brackets. So if I call whatever is on the first position of this list, it's going to be my matrix. So I have an object with 2 dimensions sitting on the first position of my list. On the third position, I have just a vector. So each object on a list is very independent from each other, and you've just grouped them together to keep organized, or because you're going to run a command to all of them, and you want to, if they are together, we'll see later with loops and several functions that work in all the elements of an object at once, that lists can become very handy. That's it. That's what I wanted to cover for the types of objects you can have in R. As usual, in the notes for the series of our introduction videos, you're going to find a little bit more material about all the classes in R and also all the scripts for this video. You can visit the VetSim project website to get these notes. Don't hesitate to send me an email if you have any questions, and in the next video we're going to tackle a little bit more on functions and then finally bringing in data sets.